All right. Okay, so these are all our parameters, all our information that we have to stay inside, and so we're minimizing cost. So let's go ahead and draw our figure here. Whoop. And our variables, this will be R, this will be H, and that's all the variables we need. Okay. So let's go down the informational stuff right here. We know it holds 100 pi meters cubed, so that tells us about our secondary equation. We know we're going to be dealing with volume. But we want to focus on the primary equation first. After you draw your model with good variables there, okay, we want to find the primary equation. So that happens to be what we're minimizing, and we're minimizing cost. So we need to make an equation. Cost equals something. What does cost equal? The top and bottom plus the sides, okay? So we know the top is $20 per meter squared. That's $20 times the area. The area of the top and bottom. Plus $10 times the area of what? The side. Okay, so what we have to do is we have to create an equation for the area of the top and the bottom so we can plug it into our cost formula. The area of the top and the bottom happen to be, what formula is the area of these two objects on the top and the bottom, these two surfaces? Not 2 pi r, pi r squared for both. So what? 2 pi r squared. 20 times 2 pi r squared. All right. Just a little far away. Let's zoom in. Okay. Plus $10 times the area of the sides. Who remembers what the area of the side happens to be in this situation? Let's roll it out. Not pi r squared. What's that? 2 pi r. That's the circumference. And this is? That is h. So 2 pi r h. Alright, so this junk becomes 40 pi r squared plus 20 pi rh. We have our primary equation. There's a problem with the primary equation. It has too many variables. So we use our parameters that were given, the volume, as a secondary equation. We know that secondary equation, the volume is of any prism is equal to big base times height. I call it the big base because it's the area of the base, not just the length of the base. So volume equals, what's the area of the base? Pi r squared times the height. Okay, now so what we're given is 100 pi for the volume. We know that. It's good. We use what we know in the secondary equation Oh, I'm sorry. Yes. Okay. So when we use what we know in the secondary equation, there's 100 pi units of volume. Okay. So let's look at our primary equation. Which one of these things looks easier to replace? The h. And I'm going to start doing this to where I draw symbols for what I want to substitute for, because for some reason it's easier if you have a visual thing that you know you're going to go back to substitute. Alright, so everybody solve for h. You got it yet? Solve for h. What do I end up with? What do I end up with? Come on. 100 pi over pi r squared, which really gives me 100 over r squared. Alright, so let me zoom in a little bit more. So we have 100 over r squared for our height, and what are we going to do with that? Yep, because this is now where I need to substitute that in there to make my primary equation viable and usable. Alright, so now C is equal to 40 pi r squared plus 20 pi r 100 over r squared. I want y'all to simplify that to where you can actually take the derivative of it. Everybody go. You got 30 seconds. Less than that. 15. Come on, what happens when we take that 20 pi r and we multiply it times the 100 and all that good stuff? 2,000 pi r, is that what you said? Yes? No, you cannot. This has an r squared, this has an r. Oh no. I was like, either something's wrong with my computer or something morbid is about to happen. Alright, so 40 pi r plus 20 pi r, you can't combine those. What you can do is combine the 20 times 100, that's 2,000 pi r all over r squared, and what happens from here? Cancel out an r, and you end up with really 2,000 pi over r. Well, I don't like that. I want to take the derivative of not that, and so I'm going to flip it. 2,000 pi r to the negative 1. Now let's take our derivative and set it equal to 0. Go, go, go. Power rule. That 40 pi, that 2,000 pi, they do not matter. They do not matter. They should not stop you from doing what you're doing. They're multiplying constants. You don't care about them. So our power rule, C prime is equal to 80 pi, this is what you should have got, plus, sorry, minus 80 pi r, sorry, minus 2,000 pi r to the 200. Oh, I did. pi r to the -2. Very good. All right. And we're setting this all equal to 0.
Teachers and students, pardon this interruption. We are going to continue to honor our veterans today with a special moment of silence that will begin precisely at 11 a.m. On November the 11th, 1918, an armistice was signed between the United States and its allies in Germany for the ending of hostilities on the Western Front of World War I. This armistice took effect at 11 o'clock in the morning, the 11th hour of the 11th day of the 11th month. That is today. World War I was supposed to be a war to end all wars. Unfortunately, as you know, that was not meant to be. As we pause for 1 minute of silence, let us remember our veterans who have served and continue to serve this great country so that we can enjoy the freedom and liberty that we have. At this time, please stand and pause for 1 minute of silence. Thank you very much, and thank you to our veterans and their families for their sacrifice. Let's make it a great day, and go Big Blue.
No one was pointing at the flag. Everyone was looking away from it.
I don't know. All right, here we go. So we got to isolate R. There's two ways of doing this. You could get common denominators, right? All right. Or you could just minus that over and then multiply both sides by R squared. Okay, so let's do that.
Wait, what did you say?
Minus the 80 pi R over
Oh, and then multiply by...
R squared. We end up with negative 80 pi R equals negative 2,000 pi over R squared. And if you multiply both sides by R squared, it should be easy from there on out. You can divide by negative 80 pi after you multiply. What do we get after we divide both sides by 80 pi?
Yeah.
By the shuffle of calculators, that means you're doing it right now. Multiplying that to both sides yields negative 80 pi R cubed. Alright, y'all should have already divided both sides by negative 80 pi. That sounds like a sorority. I'm sorry. I don't need to get off task. R cubed equals not 25 pi, just 25. The pi's cancel. And then I take the third root and R is equal to
Divide by negative 80. To get 25.
divided by negative 80 pi.
Oh, yeah.
That was right, like you wrote that.
All right, so that's 2 point what?
924.
Now that is correct for that, but I also need to find what? The cost. Well, not necessarily. I need to find the dimensions. All right, I want to find the dimensions that minimize the cost. So I have R. I also need H. I need H.
924.
Okay. So what equation is going to help you find H? I could use the original all the way up here, but that would be silly. I want to use this one. But if you just plug that into there, hold on. Let's do a big check for my substitution. Anytime I do a substitution, I like to include some sort of yes, insignia. So if I plug 2.924 in, I'll be wrong. All right, we talked about this yesterday.
Yeah,
Because it's not the whole decimal. 100 divided by 2.924 is incorrect, or 2.924 squared. That would still be incorrect. It's close to the answer. It's not exactly accurate. So let's do this. Let's put the third root of 25. 25 caret 1 divided by 3. 2.92. That's the third root of 25. Let's stow it. Hit the STO key. Hit the stow key. And we're going to store it as R because it is R. So hit alpha. Hit your alpha, and your R should be your multiplication sign. I know you can't see it on the video. Yeah, it's hard to see. You're going to hit alpha and then multiplication sign for R. Alpha R. Then stow it as R. Yeah, you have to hit enter. And now that it's stored as R, you can just do 100 divided by R squared. Alpha R again. 100 divided by R squared. All right, so let's note what our answer was right here. 11.696. Let's see if we would have been correct if we had done it the other way. 11.69, but I think the decimals change right here.
Yeah, they are different.
They are different, but we would have got lucky. But what I'm saying is you will not get lucky every time. You need to store your rounded decimals and use that. And plus, it's easy. You don't have to type it in. You just type R, especially if you're plugging it into something big. So 100 divided by R squared was my height. So height is equal to 11.696. Now let's look at our question and see if we satisfied it. All right, it says to a cylindrical can cost 100 pi meters cubed. The material for the top and the bottom costs 20 meters squared. Find the radius R and the height H of the most economical can. So we've done that. We found the radius and the height. So that deserves a boom. Or mood. All right. Any questions? It does. It does forever. So your R will stay 2.924 until you change it. Yep. It'll stay 2.924 until, or you clear your memory. All right. So that's number 6. Let's move on to number 7.
Number 8.
Number 8. We're skipping 7.